Hello, everyone. Today's success criteria is that I can solve advanced logarithmic equations. Okay, so within the questions that we have below, or the equations we have below, we're going to have to utilize the properties of logs that we learned earlier in this unit. So we have a few properties. Again, if you have an exponent that can become a coefficient, that's number one. Property two is if you have a product of two things, we can call it a sum of two logs, and we can go backwards too. If we have a sum of two logs, we can create a product. And then last but not least, if you have a quotient or division of two arguments, we can turn that into a difference of two logs or subtraction of two logs. So what we're going to do is, for the first few examples, we're going to have to condense these problems down into one log, and then we're going to use our tools to solve that log equation, okay? So if you look at example 1, it says that I have the log base 4 of x plus the log base 4 of 2 is equal to 2, okay? So what I'm going to do here is I'm going to condense this down so that it is now the log base 4 of x times 2 is equal to 2. Again, the two logs on the left-hand side of your equation are being added, so that means that I can write it as one log and multiply the insides of those parentheses together. So if I write this a little neater here, rather than saying x times 2, I'm just going to call it 2x. So that gets me here. All right. Now, the next step is we have to get rid of the log. We have to use some inverse operations. Now, we learned in an earlier video, the inverse of a log is to use power. Okay, so what I'm going to do is, because the base is 4, I'm going to use base 4 for both sides. Excuse me while I get my stylus to work here. It's being a little fidgety. There we go. Of 2x is equal to, and what you do to one side, you have to do to the other. So if I have base 4 on one side, I have to use a base 4 for my exponential on the other side. So now when you have the base of your power matches the base of your log, those cancel, and all I'm left with here is I'm going to have a 2x is equal to, excuse me, let's get this pen working here. Sorry, let me see if there's a problem with the battery. Okay. Is equal to 16. And we're going to divide the 2, and I'm going to get x to be 8. All right. Now, one thing that we want to do whenever we're done with these is we want to check for any extraneous solutions. So what I'm going to do is I'm going to take x, I'm going to substitute it back in to my problem. Now, rule of thumb, you can have no negative values inside a log. Okay, so this is a big note. You can have no negative values inside of a log. So if I plug 8 into this, I'm going to have the log base 4 of 8 plus the log base 4 of 2, and that's equal to 2. Now, you can combine these together to say the log base 4 of 16 is equal to 2. And if you did the log base 4 of 16 in your calculator, so if you did that log base, you would get 2 is equal to 2, which checks out. Okay, but the big note is, notice that the 8 and the 2 inside those logs were positive values. In that case, I'm probably not going to have an extraneous solution. Okay, so we'll take a further look at those in a minute. So if you take a look at example 2, now we have a subtraction of two logs, which means I'm going to combine those together. All right, so the log, and because it's a subtraction, we're going to use the other property, which means I need to have division. So be x over 2 equals 3. So we condensed it into just one log so that we can solve it. Now, we need to use the base in order to get rid of the log. So we're going to create some exponentials on each side. So the base, now remember, I keep bringing this up in all the videos. If there's no base written, it is always a base 10. So I'm going to use 10 to one side, 10 to the other side. If I say 10 to the log base 10 power, those cancel, and I'm left with x over 2 is equal to 10 to the third power. Now, I'm going to take my calculator. I'm going to do 10 to the third power, which gives me a value of 1,000. Now, to solve this, I need to get rid of this 2, and because it's divided, I'm just going to multiply both sides by 2, which gives me x to be 2,000. And this would be my final answer. Now, I am going to check for extraneous solutions. So I'm going to take and I'm going to plug this in. I'm going to say the log of 2,000 minus the log of 2 is equal to 3. Now, there are no negatives inside the log, so we're on a good path here. So far, I think we'll be okay with extraneous, but I am going to check. I'm going to say the log, and because it's subtraction, I am going to divide. And if I divide, I get the log of 1,000 is equal to 3. And if you type in log of 1,000 into your calculator, you do get 3 equals 3. So that does work. So again, I'm checking for any extraneous solutions. All right. Now, the following examples will probably have more extraneous solutions. So example 3 and 4. So again, I have 2 logs. Those 2 logs are being added together. So we want to start by condensing it. Now, you have to be very careful. I want to change to a red pen here. So if I have the log base 2, and if I multiply x plus 6 to x, you're going to have to distribute that to both. I need to multiply x to both of those terms, which gives me an x squared plus 6x is equal to 4. Okay, so now we go about it the same way. So what I'm going to do is I'm going to raise both sides using base 2 power. Those cancel, so I get an x squared plus 6x equals 2 to the 4th. Now I actually want to know what 2 to the 4th is. So 2 to the 4th, if I type that into my calculator, I get a value of 16. Okay, I'm going to subtract that 16 over to the other side because you can see here we have a quadratic. So that's going to be equal to 0. And how do we solve a quadratic? Well, the first method that I have is factoring. If factoring doesn't work, then we can use quadratic formula. Go on from there. So if I factor this, I need to know factors of negative 16 that add up to 6. I'm pretty sure are going to be an 8 and negative 2. Okay. And if I solve that, I get the answers of negative 8 and positive 2. Okay. So these are my 2 preliminary solutions. Now, I do want to see if any of those are going to be extraneous. So I'm going to say, okay, so I'm going to check these answers. I'm going to say the log base 2 of negative 8 plus 6 plus the log base 2 of negative 8 is equal to 4. And if you look here, if we reduce this a little bit, okay, you can see the insides of these logs, the negative 2 and the 8, are negative. You can't have that. So therefore, 8 has to be an extraneous solution. You can't take the log of a negative value. All right, so that would be extraneous. Now, I can check the other solution just to double check. I'm going to say the log base 2 of 2 plus 6 plus the log base 2 of 2 is equal to 4, which will give me the log base 2 of 8 plus the log base 2 of 2 is equal to 4. And because these are being added, we would multiply the insides together. So 8 times 2 is 16. And if you did log base 2 of 16 in your calculator, you will get 4 equals 4. So our solution, the only solution that we get here is going to be 2. Okay. Now that was a lot, so I have another one just like it. We're going to take it step by step and let me know if you have any questions. Okay. So I have log base 4 and a log base 4. They're being added together. So what I want to do is I want to start with multiplying the insides. Now, if I do x times x, that's going to be an x squared. X times the 30 is going to be a 30x, and that would just be equal to 3. Okay. Now, I need to solve it. I need to get rid of the logs. So we're going to use a base 4. So if I do base 4 to both sides, I'm left with just the inside of my log. So x squared plus 30x is equal to 4 to the third power. Now, if I check my calculator here, 4 to the third power is going to be 64. I'm going to subtract that over to the other side. So I'll say minus 64 equals 0. And I can now factor. So I need to know factors of a negative 64. So two numbers that multiply to a negative 64 that are also going to add up to 30. And I'm pretty sure we're just going to get 32 and a negative 2. And that will equal 0. So our solutions, our preliminary solutions to this are going to be a negative 32 and a positive 2. Okay, so now what we need to do is we need to check to see if any of them are extraneous. So if I take the log base 4 of a negative 32 plus 30 plus the log base 4 of a negative 32 equals 3. Now you can see already that this second log has a negative value on the inside. That is not possible. I cannot have a negative inside of my log. So I'm going to check the other solution. I'm going to say the log base 4 of 2 plus 30 plus the log base 4 of 2 equals 3, which gives me the log base 4 of 32 plus the log base 4 of 2. And if they're added, I multiply the insides together. And if you did log base 4 of 64 in your calculator, you will get 3 equals 3. So that will be my solution. So the solution to this question is just x equals 2. Okay, now it is possible to have two solutions. I do want to make that aware. It is possible to have two solutions to these questions. All right. Now the last example I think is probably the simplest. It makes the most common sense. If you have the log base 5 or log any base of something equals the same log with the same base, now you already have the logs equal. So ultimately, in order to make sure that this equation is balanced, we just need to make sure that the inside of the left side is going to equal the inside of the right side. So if you ever have two logs equal to each other, then I know I'm just going to have a 2x minus 8 is equal to 14. I just need to know when those two things are equal to each other. So if you add 8, okay, I get 2x equals 22. Divide the 2, and I get x to be 11. Okay? And again, that would be your solution. You could check that. It does work. Always check your answers. So we had three kind of types of problems. We had just kind of, can you condense, get rid of the log and solve, right? So we don't want any negatives. Make sure you check your answers. So we condensed using multiplication because it was plus. We condensed using subtraction or division because it was a minus. But then we had two that were a little bit more complicated. And the reason they were more complicated is because when I condensed them, the result that I got was quadratic. And, it takes a little bit more steps to solve a quadratic using some factoring. So, make sure when you condense, take a look at what you have and make sure you take the appropriate steps to solve. And then the last problem we had was when we have two logs of the same log, same base, when they're equal to each other, we can just set the insides of those or the arguments of those logs equal to each other. And that would end up giving me my answer. Okay, I hope this helped. Please email me if you have any questions. Hope to hear from you soon.